Here's a video for lesson 10-2, area of 3 different shapes, trapezoid, rhombus, and kite. We're actually only going to use 2 different formulas for those 3 different shapes, so let's get right into it. All right, the first thing we'll talk about is our trapezoid. All right, a few things to remember about a trapezoid. We have a picture of it here. We have 2 parallel sides called the bases and then 2 non-parallel sides. All right, what you need to find the area of a trapezoid is the height, how tall it is, and the lengths of its bases, the parallel sides. So that's what we need to know. We need 3 measurements to use in order to find the area of a trapezoid. So when I say height of a trapezoid, I mean this perpendicular distance between the bases. So on the picture here, the bases are the parallel sides. I need to know the perpendicular distance between them. All right, so I need to have that right angle shown there. All right, then after that, we have the parallel sides. It doesn't matter which one's base 1 and base 2, but take a second to take note of the formula here. It's going to be similar to our triangle formula, 1/2 the base times the height, but this time it's half the product of the height and the sum of the bases. So what we need to do is add those bases together. So that's our formula. Let's jump right into trying to use it. All right, we're going to try to find the area of Nevada. Nevada is a trapezoid in shape. So we're going to look at finding the area of Nevada. The formula for that state would be the area of a trapezoid formula. So what we need to figure out is the 1/2 the height times the sum of the bases. So it's a good place to start like this, and then maybe just make a little list. Do we know all of these things? Do we know the height? Do we know each of the bases? If we do, we can plug it in. If not, we might have a little bit of work to do at the beginning. So with this picture, we have 205 and a 511. So the bases are not the top and the bottom this time. They end up being the left and the right. Choose one of them to be base 1, one of them to be base 2. It doesn't matter which one's which. So we do know both of the bases this time, which is good news. We also know the height. The height is the perpendicular distance between those bases, so our height is 309. So we do have all 3 numbers that we need this time in order to solve our problem. So I'm going to go ahead and start to plug things in. We have our 1/2. The height is 309 miles. Our bases are 205 and 511. All right, so I would go one more step before we look at the calculator. I usually, just to avoid any calculator mistakes, I usually add the 2 numbers in the parentheses first and then go to the calculator after, just to keep things a little bit simpler. So what we're going to punch in this time is 1/2 times 309 times 716. We end up with 110,622. We are area, so we're in square units, so square miles this time. So that would be the approximate area of Nevada. All right. Looking on to the next one. It says, what is the area of a trapezoid with height 7 and bases 12 and 15? So again, do you know the formula? It's a great thing, a great habit to just write down the formula first and then make a little list off to the side. Do we know these things? This time they gave them right to us in the word problem. No picture, but that's okay. We know the height is 7. We know we have a base of 12, and we have a base of 15. These are all in centimeters, so we don't have any unit issues. We're ready to plug in. So we're going to go ahead and take 1/2 of 7 times 12 plus 15 for our 2 bases. All right, again, but just to get to the calculator step, probably a good idea to add the 12 and 15 and get your 27. And then you can go to the calculator from there. When you punch that in, your area, your final answer is 94.5, or in centimeters squared. That's area of a trapezoid. All right, if you know the height and you know both bases, it's just plugging in to a formula. All right, sometimes you do not know all 3 of those things, and we'll show you one example of that right now. In this trapezoid, we know we're finding the area of a trapezoid, so we know that this is the formula we need. 1/2 the height, the bases added together. All right, if you make your little list here, they did not give us all 3 things in the picture. So this one's kind of a challenging problem right away. We have 7 and 5 that were given to us. Those are going to be our bases. So we know that we have both bases. What we don't have is the height. So the question this time is, how tall is that? We don't know the height. We have to figure out the height of the trapezoid by kind of a review problem. The way that we would do it is noticing that we have a 60 degrees over here in this corner. If there's a 60 degrees in this corner, then I can make another line here that's also perpendicular. So this is going to represent my height. And now I have a 30, 60, 90 triangle. So the trick with those was to figure out what your short leg is. This right here is my long leg. To get from the short leg to the long leg, it was a trick of multiplying by square root of 3. So if I can figure out how long this little short leg is right here, then I can multiply that by square root of 3 and get that height. So for this one, I know that up top we have 5 meters, which means that down here we have 5 meters. And then I know that the total is 7, which means that this little piece has to be 2 meters. They have to add up to 7. So like I said, all we're going to do is multiply that by square root of 3. So the height is 2 square root of 3 meters. So there might be some special right triangles. There could have been a 45 down there for the angle, and that would have just made our strategy just slightly different. So now that we have all three, we're ready to punch in. We're at the step where we just plug everything into the correct space. 1/2, 2 square root of 3, and 5 plus 7. So what we have here, if I add those together, you can certainly go to the calculator for this problem, but sometimes it might say leave it in simplest radical form. So to do that, I would notice I have a 1/2 and a 2 that are just going to cancel. All right, and then that means I have a 12 and a square root of 3 left over. That's a good exact answer in square meters. All right, if they asked for us to round it, we could certainly punch 12 square root of 3 in. We end up with 20.78 meters squared as our rounded answer. So we would just have to read directions on that one on how they wanted us to answer. This time it didn't say either way. So the next part here, what I'm going to have you do is pause the video and try to work through these three. All right, 3 problems on finding the area of a trapezoid. Why don't you get started on that? And then when you've tried all 3, go ahead and resume the video, and I'll just pop the answers up right on here. Okay, you should have tried all 3. Just check the work that you put in, and that I'll get you to the calculator step, and then you can just make sure that you had the correct answers. So there wasn't any tricks for these ones. For that first one, 10 was your height, 9 and 16 were your bases. When you plug everything in the calculator, you should have got 125 square feet. Second one, 7.5 was your height, 9 and 22 were your bases. So 1/2 times 7.5 times 9 plus 22, which is 31, would have given you 116.25. And lastly, we have our 1/2 times 7 times 4 plus 13, which would come out to about 59.5 square yards. So hopefully those 3 went okay. Trapezoids can be pretty straightforward if I give you everything, or they can be a little tricky if you're missing the height or something like that. So we'll continue to practice a lot of those types of problems. All right, next thing we got to do is talk about rhombus and kite. They have the same formula, so they have a lot of things in common. One thing they have in common is the formula to find the area. So theorem 10.5 in your notes is going to be for finding the area of a rhombus or a kite. All you need to know is the lengths of the diagonals. All right, so remember that rhombus and kite, all we need to know to find the area are the diagonals. We need to know both of them. Because all we need to do, if you look at this formula here, not very complicated formula, the area of a rhombus or a kite, same formula for both shapes, is half the product of the diagonals. It's half the product of the diagonals. If I know the diagonals, I can just multiply them together and divide by 2. That's going to be your formula for the area of a rhombus. So let's look at that. We want to look at the area of this kite, KLMN. The area of a kite formula is the one we just had looked at, it's 1/2 the diagonals multiplied together. So 1/2 times diagonal 1 times diagonal 2. So sometimes you'll get set up this way and you need to be able to tell me what the diagonals are. It doesn't matter which one diagonal 1 is and which one diagonal 2 is. All right, so say we were looking at Km for diagonal 1. Well, that would mean that I have a 2 here and a 5 here. I have to add those together to get a total of 7 meters for diagonal 1. That means diagonal 2, if I use Ln, the other one, I have a 3 for both of them, 3 plus 3 giving me 6. So for this one, I need to take 1/2. Diagonal 1, I have my diagonal 1 is 7 this time, and diagonal 2 as 6. So I have 1/2 of 42, which is going to be 21. So the area of this kite is 21. We are in square meters this time. Moving on here, same thing with no picture. What is the area of a kite with diagonals that are 12 and 9 inches long? Well, they gave us D1 and D2. They told us that they are the diagonals, so we don't have to do any adding of any diagonals together. So I know my formula. I'm looking for area of a kite, so 1/2 D1, D2. And I know that diagonal 1 is 12, and I know that diagonal 2 is 9. So I have nothing to find this time. I'm ready to try and solve. So I'm going to punch in 1/2 times 12 times 9 in the calculator. Will be 1/2 of 108, which is 54. This time we are in square inches. So sometimes it's even faster without the picture because we don't have to add any diagonals together. Okay, that's kite. Let's look at rhombus. Same formula. Find the area of each rhombus is what it says. You might need a little bit of chapter 6 memory for this. A rhombus is also a parallelogram. We have a situation where the diagonals are cutting each other in half. So if I have this diagonal here, I know that if this is 20, then this one has to be 20 as well. So I know my formula is going to be 1/2 times diagonal 1 times diagonal 2. All right, for diagonal 1, the one that I have highlighted already, it's like doubling the side that they gave us. They gave us 20, which means the other side is 20. One of the diagonals is 40. This 30 would be the same as this piece of the diagonal, so I know that diagonal 2 would be 60 feet. All right, so be careful. Some people don't remember to double those numbers in there on the rhombus, so then they end up with something that's a little bit too small for their answer. So we have 1/2, and one of the diagonals is 40, and one of the diagonals is 60. So I have 1/2 of 2400, which is 1200. This time I am in square feet. Okay, here's a tougher rhombus one right away. This one, the reason it's tougher is because of what we're just talking about. So if we try to make our list, we know that our formula is going to be 1/2 diagonal 1 times diagonal 2. If I try to make my list here of my diagonals, I know that this is 8, which means that this is 8. So one of my diagonals is 16 inches. All right, then the trickier part is finding diagonal 2. The reason diagonal 2 is a little bit trickier this time is going to be because I only know that this hypotenuse is a 10. I don't know how long each of these are. I know that what I need is that green diagonal. If I can figure out one of them, I can figure out what both of them are when I double. So what I know here, rhombus have perpendicular diagonals. So that means I have a right triangle right here, and I have 2 of the 3 sides. I have C and I have either A or B. So I need to figure out that side. What I'm going to use is Pythagorean theorem. So A squared plus B squared equals 10 squared. Okay, so this is actually Pythagorean triple. A squared plus 8 squared equals 10 squared. Okay, so that means I'm taking the square root of 100 minus 64, which is 36. This side here has to be a 6, which means this side has to be a 6, and this is a 12. So I know both diagonals. I have a 12 and I have a 16. And then we can go and we can start to plug in. So let's do that. We have a 16 and a 12. So we have 1/2, a 16, and a 12. So you can think about it as 8 times 12 if you want. Or you can just punch it all in at once, and we're ready to get our final answer. So that's going to be 1/2 times 16 times 12, giving us 96 square inches. So that one was a little bit tougher because we didn't know one of the diagonals, or even a piece of one of the diagonals, and we had to use Pythagorean theorem, some right triangle review, to figure that out. These ones should be a little bit more straightforward. No picture is actually usually easier, as long as they don't do any weird stuff with units. They gave us 2 diagonals. We're finding the area of a kite. The area of a kite is 1/2 the diagonal 1 times the diagonal 2. All right, so then what we get with that is just ready to plug in. 1/2 times 12 times 3. So you can go to the calculator for that if you need to. We're going to end up with our answer, our area, which is going to be 18 square feet. Same thing over here. They changed the word to rhombus, but that doesn't change the formula at all. 1/2 diagonal 1, diagonal 2, and they gave us both diagonals. One of them is 9, one of them is 6. So I have everything that I need. 1/2 times 9 times 6. Half of 54, which is 27 for our final answer, square yards. All right, now we're into a tougher word problem. All right, so we're getting near the end of the notes, but this one is more of a challenging type because they don't give us a ton of information here. They kind of come at this a different way. So this one says one diagonal of a rhombus is 5 less than twice the other diagonal. That's going to be something we'll need to use algebra to represent. So we'll come back to that one. They tell us the answer this time. The area is 75. So they told us the area, which is going to be just a kind of a little bit of a different approach. So the question is to find the length of each diagonal. So we're going to come back, we're going to remember what we need to find is the length of each diagonal. That's what the question is. So this can be a pretty challenging problem. It's going to involve some algebra review. It's going to involve some factoring. So they told us that we have the area of a rhombus. So 1/2 diagonal 1 times diagonal 2. We don't know what either diagonal is. That's what we want to figure out. They told us that the area is 75. So I'm going to plug that in for capital A. So we know that that's 1/2, 75 equals 1/2 times the 2 diagonals. So I need to try to figure out something to represent those diagonals for the time being. I need a placeholder, I need some algebra. So I know that one diagonal is 5 less than twice the other diagonal. So all I'm going to do for the first one is just call it x. We're just going to say that first one is just x centimeters long. All right? The second part is where we go to that 5 less than twice thing. All right? So I know that the other diagonal is 5 less than twice of x. So twice of x would be 2x, but this diagonal is 5 less than twice of x. So 2x minus 5 is another way to say 5 less than twice the other diagonal. So if I call one diagonal x, the other one would be 2x minus 5. Let's plug that in over here. We have an x and a 2x minus 5. All right, so then for this problem, it might be best just to get rid of that 1/2 by doubling both sides. All right, that would cancel over here, and now I have 150 on this side. All right, and then I have a distributive step. So x times 2x will be 2x squared. X times -5 will be -5x. Now I have an x squared, and we saw this a lot in prior chapters this semester. As soon as you get an x squared, now you have to think about factoring or quadratic formula. So before we do any of that, we need to make one side 0. So I have 0 on one side, 2x squared minus 5x minus 150 on the other. You can feel free to use quadratic formula on that, the big x equal to -b, blah, 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 all that stuff. I'm going to factor it. All right, this one does factor, and it factors pretty nicely. I know that 150 is a big number, all right, but we know that we have a 2x out front, which means I need a 2x and an x for my first terms. All right, once I factor this, I can look at my solutions. I'll probably get one good solution and one bad solution, one that wouldn't make any sense. So I need to multiply to 150 and add to -5. All right, if I look at the factors of 150, all right, a couple of those are 10 and 15. If I put a -10 on this side and a +15 on this side, what I end up with is 2x squared, and I have a 2x and a -10 making -20, and a 15x making +15. I have -20 from these two, and I have +15 from those two. That's going to be my -5. So I know I factored that correctly. All right. So this is the factored version. Again, if you couldn't figure that out, or if you'd rather use quadratic formula, you're certainly welcome to do that. This gives us two possible answers. One where 2x plus 15 is 0, and one where x minus 10 is 0. Again, that's why we set one side equal to 0 when we do this. The solution on the left here, I would have to subtract 15 over. So now I have a negative. So this answer is -15/2, or -7.5. This answer doesn't make sense. My diagonal can't be negative. All I have to do to solve the one on the right is add 10 over. So x is 10 is my value of x this time. But now, after all that work, I have to think about what the question was, which was the length of each diagonal. So I need to take that 10 and plug it in to find my answers now. So I know that diagonal 1 is just x. So I know that diagonal 1 is 10 centimeters. Diagonal 2, I'm going to plug in 10 here. So 2 times 10 minus 5. That's 20 minus 5, or 15 centimeters. So that's a very, very high level question just because of the amount of steps and just because of the way that they had us approach it. They gave us the area first and asked us to work backwards a little bit. And then the algebra was set up to be a little bit mean to us. All right, this next one is not quite so bad. This is back to trapezoid. So just switching formulas again. That was the one where we did 1/2 the height times the bases added together. So this one, they did give us everything we need. They gave us 2 bases and they gave us a height. So I'm ready to plug in already. The height they gave me was 5, and then I had bases of 20 and 14. Again, before you go to the calculator, my advice, add the 20 and the 14 together. Then your calculator won't do things in the wrong order for you. All right, so that's going to be 1/2 times 5 times 34, or 5 times 17, if you want to think about it that way. It's going to equal 85 square centimeters. All right, last page of the notes here for 10-2. I want you to work on these 6. Just work through them, see how you can do. Again, when you're done, you can resume the video and just check your work. I'll have the setup and the answer for all of them. There should be no tricks in here. Just do your best and try to get each one right. Try to go 6 for 6. Go ahead and pause the video now. Resume when you're ready. All right, hopefully you've had a chance to look through and try all of these. All right, the top one, number 1, is a trapezoid, so the formula is there. You should have had 1/2 times 6 times 4 plus 10. Multiplying all that together, you should have got an answer of 42 square meters. Here, the second one, another trapezoid. The height is 18. The bases are 15 and 27 for a total of 378 square inches. Third one, they gave you pieces of the diagonal, so make sure that you have the same thing I have here. A diagonal of 6, which is the 2 3s added together, and then there's really 2 5s there added together for this rhombus. So we have 30 square feet for that answer. Down here, make sure, again, that you doubled both of those 12s. Your work should look like this: 1/2 times 24 times 24 for an answer of 288 square inches. We have a diagonal for number 5 for this kite. We have a diagonal of 20 and a diagonal of 30. So make sure your work shows that. 1/2 times 20 times 30 is going to give you 300 square meters. And last but not least, this kite, you have 2 diagonals of 4. They're 4 each, 3 plus 1 and 2 plus 2. So 1/2 of 16 or 8 square centimeters. So that's going to be what you need to know for trapezoids, rhombuses, and kites. All right, now that you've seen the video and taken the notes, you should be able to have some success on the worksheets. All right, again, make sure that you're always writing down the formulas and listing what you know and what you don't know. All right, go ahead and get to it.